These are the main group elements. These are the numbers of the groups. In our very first video, we talked about group number 1, which includes hydrogen. In our second video, we examined the ionic bond between fluoride ions and lithium ions. Now let us see if there is another way for the atoms to gain a stable outer shell of 8 electrons. Fluorine has got 7 electrons in its outer shell. It needs 1 electron to get its full 8-electron configuration. Those are 2 fluorine atoms. What other way do they have to get their full 8-electron outer shell than to accept an electron from another atom? Stop the video right here and let me know in the comments section. Exactly. They can share their electrons, which are missing to fill up the outer shell to 8 electrons as shown in the image. Those are the 8 electrons of the full outer shell shown in red. By that, the other atom also reaches an outer shell of 8 electrons. Those 2 electrons are shared by both atoms. They are forming the electron pair bond. The bond is also called covalent bond. Those 2 atoms are forming a molecule. So, a molecule does not have to consist of different atoms. Elements, such as oxygen, nitrogen, chlorine or fluorine, also consist of molecules. This is the electron configuration of the element neon. It's a noble gas. Why does it consist of atoms and not form molecules? Please let me know in the comment section. Now we will write this molecule in a different way, which makes things easier. Only the electrons from the outer shell are shown. Can you point out where the electrons from the covalent bond are? Here are some atoms written with their electron configuration. Can you point out which group in the periodic system they belong to? Now let's address one final topic. Here is the atom of neon again. I had oversimplified the electron configuration. In more detail, it looks like this. The 2 first electrons are in their own shell. But this shell only consists of 1 subshell, called 1s orbital. The second shell consists of 2 sublevels, the 2s subshell and the 2p subshell. This is the 1s subshell with 2 electrons. This is the 2s subshell with 2 electrons. This is the 2p subshell with 6 electrons. All the elements have got an electronegativity. Those are values, calculated from properties of the atoms, such as the ionization potential. The value of the electronegativity shows how strongly the atom is pulling the electrons towards the nucleus. This has an effect on our covalent bond. Here is the molecule of hydrogen fluoride. Hydrogen has got a value of 2.1, fluorine has got 4.42 according to the Mulliken scale. Fluorine is pulling the electrons stronger towards its nucleus than hydrogen. The result is a so-called polar bond depicted by the wedge in the middle.